revisit it and benefit from it. So recording is started. I will hand it over to our Unicorn colleague who will take us forward in this today's webinar. So thank you everyone, and yeah, Unicorn team, it's over to you.
Yeah, thank you, Pushpendra, for the intro. Hello and welcome once more on today's webinar, which will be focused on the high availability setup, as Pushpendra already mentioned. My name is Daniel Janota, and I'm currently an analyst of ECCo here in Unicorn. And together with me, there is Michael and Thierry.
Hello, my name is Michael Pinkas, and I have been working on ECCo as developer.
Hello, my name is ECCo, and I work as ECCo software architect.
During the presentation, if you have any questions, please just raise your hand here in Teams, or you can also send your question to the Teams and we will get back to it. Regarding the agenda of today's webinar, we will start with some new features in the last two releases, so spring and fall releases of this year. We'll do just a quick comparison with previous version, specifically the comparison of the deployment, which has changed a bit. Then we will go through some prerequisites and general information before the installation. So we will check some documentation, maybe check the database, setup requirements, hardware requirements, etc. Then we will go through some configuration of the ECCo client, so some command configuration, and specifically the internet broker configuration. And then we will also configure the ECCo client application cluster. We will also check some integration with the cluster, and that all will be covered by the practical demonstration in the second part of this webinar. So let's start with new features in the past releases. Regarding the comparison, as you can see, there are two pictures. The one on the left side is the ActiveMQ deployment, so that one applies for all the version from like 4.12 and like older, so lower versions. There you can see that the embedded ActiveMQ internet broker was used. It's embedded to the application itself, so the ECP endpoint or EDX toolbox, and it was together with the ECP endpoint or EDX toolbox connecting to the external database, or also some local database if required and if configured. On the right side, then we have the new design of deployment. We call it Artemis deployment. This deployment is used since the ECP 4.14, which is this year's spring release. And as you can see, the ECCo drone broker does not use the external database anymore. It uses shared file journal in case of high availability. The external database for ECP endpoint and EDX toolbox still remains the same. But we will get to it in a bit more detail later in this webinar. Regarding some other changes that happened, some major changes, all the configuration properties related to the embedded broker were removed. So all the JDBC properties for the internal broker, the external broker properties, and active credentials were removed. And also, as the Artemis does not use the database, all the ActiveMQ database tables are not used anymore and can be removed after the upgrade. Also, the ActiveMQ autograde tables property can be removed as well. On the screen, you can see the 3 tables that can be removed after the upgrade. Regarding some new features in Spring release, the first obvious change is the version number, which was united between ECP and EDX. So this release comes with versions ECP 4.14 and EDX 1.14. versions are now aligned, which means that there will be less confusion. And also one more thing, that the ECP version 4.13 was skipped and it doesn't exist. Regarding some changes of the operating system support, we are still supporting the same versions within this release. However, the ECP broker, component directory, and EDX service catalog are not supported on Windows anymore. So the central components are available only on Linux system. Regarding the databases, there is no change within that support. So still the same databases, still the same versions. As of some compatibility changes, the support of ECCo authentication was removed. So the LDAP authentication is the only option remaining as some external authentication. And also some naming of the Prometheus metrics differs from the ActiveMQ Classic broker because it's just a bit different technology. As I already mentioned on the previous slide, the embedded external broker was removed from the ECP endpoint, EDX toolbox, and EDX service catalog, and instead of it, the EcoSP internal broker is used as a completely separate component. Internal broker and ECP broker also comes with Prometheus metrics, and the ECP broker metrics were extended with certificate validity. So since this release, it is a bit easier to monitor the validity of the certificates on the ECP broker. The fact that the internal broker is now completely separated from the ECP and EDX applications means and makes possible the usage of multiple components like connected to the same internal broker. So like let's say several registrations of the ECP endpoint can be connected to the one internal broker. Also, it is necessary to configure some custom queue prefix, but more of that is described within the ECP administration guide. And last but not least, the EDX service catalog now validates a network configuration file name. This was made to prevent some accidental upload to wrong environment. For example, in case that you've mistaken a server and you accidentally uploaded the network configuration from like testing environment to the production one, this will trigger a validation error that the network configuration is not from the environment. Yeah, maybe just a quick question. Do you have any questions regarding features of the Spring release? Probably not. So let's continue with the fall release. So the versions are incremented. So it's ECP 4.15 and EDX 1.15. Regarding the operating system support, the support of Windows Server 2016 was removed, and instead the support for Windows Server 2022 was added. Databases still remain the same, so there's no change there. Regarding the compatibility changes, the support of old network configuration syntax, the one that does not contain the domain element, was removed. Also, the database backup and restore feature was added, so now it's much easier to backup your ECCo installations. And it is possible to do that easily from GUI. Also, the ECP endpoint now uses some command indexes for message table, which makes listening of the messages a bit more faster. Also, the endpoint will not try to connect to unreachable ECP broker. So in case that the broker has some outage or there is some configuration issue on the broker side, and it is not possible to connect to the broker, App will not try to endlessly connecting to that. And as I mentioned on the previous slide, that the ECP Endpoint tool can use some queue prefix, so it can use one shared internal broker. Within this release, this implementation was a bit updated, and it was extended by the separate queue prefix for business application queues. So basically all queues that are used to integrate to the application. Again, the question, any questions regarding this release? Well, not. So let's continue with the next part, which will be the prerequisites and some general information. All this information that I will mention within this presentation are available in the ECP system design, in a high availability and clustering chapter, the ECP installation guide in chapter installation in high availability mode, in the EDX technical design in chapter HA deployment of toolbox, and also in EDX installation guide chapter installation in high availability mode. So regarding the database setup requirements, for the high availability setup, the external database is required. The default Apache Derby database, the local one, does not support clustering, so the external one is required. As of support databases, the Oracle 19c, MS SQL Server 2019, MySQL 8, and PostgreSQL 13 are supported, so you can use those for the high availability setup. And some of the databases might require some additional configuration or specific configuration. However, that depends on chosen database system. So, for example, there's the MySQL configuration that needs the lowercase table names and maxll bucket configured some specific values. This information can be found within the documentation within the ECP and EDX installation guide, chapter external databases. Regarding the hardware requirements, a shared storage might be required or will be required for the high availability deployment. It needs to be external database, I already mentioned, and optionally it can be also the database cluster, which then exceeding the high availability also to the data layer. For the application cluster, the same hardware setup requirements are applied as for the single deployment. It's now just a bit more due to more nodes within the cluster. What's also required is the shared file system. In case of EDX, is required for DMS, some local saving of the messages. For the ECCo, so both ECP and EDX, for FSSF, in that case, the NFS is recommended, sorry. And for the internal broker shared journal, some sort of storage area network is recommended as well. You can also alternatively use the NFS. However, if you choose the NFS for the shared journal, keep in mind that it must be version 4. The previous version, the version 3, does not support all the features and it doesn't work with Artemis. Optionally, you can also use some load balancer, specifically for the GUI access and web service access. And for those purposes, the Apache HTTPD or Nginx can be used. Okay. Regarding the specific hardware requirements for the components, you can see them on the table. Please know that it's just an estimation, and real requirements might be better changed according to the performance requirements and message traffic. We also recommend the usage of virtual machines that can be easily resized when more resources are necessary. And yeah, also all these requirements apply to a single node. So you need twice as much if you want like another server somewhere. So for the endpoint and internal broker, the 4-core CPU is required, recommended at least. 8 gigs of RAM and 40 gigs of storage. The storage may differ a bit, especially when there is more message or some bigger retention of the messages. And for the EDX toolbox, there is 2 cores, 4 gigs of RAM and 20 gigs of storage, which again depends mostly on the retention of the DMS store within the EDX application. Regarding the ECCo high availability deployment, the ECCo support this type of deployment and clustering on the application level. It requires the use of any supported external database, as I already mentioned. Shared file system is also required for the message storage and internal broker journal. So again, some storage are network on NFS version 4, and optional deload balancer, which then can balance the connection to different nodes of the cluster. The high availability deployment then consists of shared external database, at least 2 ECP or EDX components or nodes, and at least 2 internal broker instances. The main advantage of this deployment is when one component goes down, the system will still continue to function. Yeah, here's again the same picture as it was before. So you can see that there are 2 nodes of ECP endpoint connected to external database and also connected to 2 nodes of internal broker, where only one of them is active, the second one is passive, and will change the status once the active one became unreachable. And both those nodes are connected to the same shared file journal, so they can exchange messages. Here you can see some other alternatives for the journal handling. On the left side, you can see the basic and recommended setup, where 2 internal broker nodes are using the same shared file journal. However, alternatively, the data can be also synchronized over the network. That's the picture on the right side. So both nodes of the internal broker will start to communicate with each other and will replicate the data. However, it is important to note that only the shared file journal approach is officially supported by ECCo. The data replication, as is on the right picture, was not tested and is not recommended due to this fact. And regarding the toolbox availability deployment, it's pretty similar to the ECP one. You can again see 2 nodes of EDX toolbox connecting to the same external database and to the shared DMS storage. So in this case, it will be again some shared storage, and also connected to 2 nodes of internal broker, which again, one of them is active, the second one is passive, and they both connecting to the same shared file journal. Do you have any questions regarding these deployment types and approaches, etc.? fully not. So everything is clear, so we can proceed with the next slide and also the next part of this presentation, which will be the configuration of the ECCo client, which will be covered by Michael.
So now we will go through the practical demonstration, and we will start with the documentation. As already mentioned, all of the information is mentioned in the documentation, but just to go quickly through the chapters themselves, we can go into start with the ECP installation guide, and let's start with the Artemis internal broker, which is covered in the chapter 7.6 and 7.7. Here we will find some general information about the high availability installation itself, limitations on Windows, and requirements for the setup. And then into chapter 7.7, we will find information on how to configure the internal brokers to work in high availability setup and what to look for. Next, we can go through the chapters for the endpoint. These would be the 8.6 and 8.7. So once again, some general information, reference to the external databases, how to set them up and configure them, in general information and so on. Then we have the configuration itself with a chapter, subchapter for just the high availability properties, followed by properties in general for both single and high availability setups. Next, going into the EDX installation guide to the chapter 6.6. In this chapter, you will once again find the information about the high availability mode on EDX toolbox. This would mention the requirements for the EDX toolbox. Compared to the ECP endpoint, we also need a shared file system for the DMS folders, possibly for tool DMS folder as well, and of course the FSSF. Once again, just the general information. Here information about the tool interface, and going way down into the chapter 7.1.2. In the chapter 7, we have all the configurations, and in the chapter 7.1.2, we have the high availability installation properties that must be changed accordingly. Above, we can see the general parameters required for single and high availability setups as well.
Yeah, there's one question from Marek. Is internal broker mandatory on the side of ECP EDX components added due to high availability functionality? I'm not sure if I understood the question correctly, but the internal broker is required in all deployment types. Without the internal broker, the ECP and EDX won't be able to send any message.
And
So
regarding the high availability part, it is not just the high availability setup, it is also for the single deployments. It's just a change that in previous versions, the internal broker was embedded in the application. Now it is external.
yeah. So Marcel has some additional question.
Yes, I have an additional question. Hello, Alexander here from Arbatov, asking for Tenet. The first question I had, will the ECCo SP front end make us visible that we are in HA mode? So is there some kind of interface that shows us that this ECCo-SP runs on HA mode?
Unfortunately not. However, there is this an interesting idea. Yeah, if you not raise this topic and maybe request some implementation change, you can always contact the ENTSO-E on the ECP at ENTSO-E.eu or raise the ticket directly to the ECCo-SP Jira if you have the access there. But on the current versions, there will be no sign of the high availability on the GUI.
Oh, thank you.
Just a quick note to that. This applies to the endpoint toolbox, the ECCo-SP applications themselves, but Artemis, in the Artemis it is visible if the node is in high availability setup and if it is master or if it is primary or secondary.
Okay, thank you.
So let's proceed. So we will start with the actual configuration. In the presentation, I will be showing the mandatory properties that we will change. It is possible to find them in the documentations. However, I will just show them in the presentation. So I have the servers connected, and I will start with the installation of the applications. I'm in the folder where I have the RPM installers, so I will quickly install all of the applications. That is done in the using the RPM-I command. Pretty simple. Also covered in the installation webinars. Now I would proceed with the configuration in the terminal. However, for better visibility, I will open the configurations using Visual Studio Code on my computer. So just to see that, I will go into the ETC ECP endpoint folder where I can find the ECP properties. I will open them. So to start, what we need to first configure is to enable the Spring for Files profile. That will be the ECP-HA, and also I will set the ECP cluster manager local instance ID. The value of this property should be unique, and it is used for the endpoint or toolbox uses it to advertise it is the master. The nodes in the cluster use it to identify themselves. So first I will set the profile, just to raise the non-HA, and then I will add the ECP cluster manager instance ID, and I will set it to some unique value. For us, I will use the name of the server where the component is installed. Next, I have the EDX, but we will come back to this later. Next, what we will have to configure is the configuration of the database. We will be using the MySQL database. So scrolling down here, we have the HA configuration. I will uncomment these properties. So I can see that I can just replace the property here. And so I will be using the MySQL JDBC connector followed by the IP address. which I have prepared in my second monitor. So to just click a bit, paste it. For us, this will be the server. Next, I have the port followed by the name of the database or the scheme. For us, it will be the web slot. And that's this. And then we have the parameters. The parameters can be a new line. This would be indicated by the slash. And we will put the auto reconnect true and character encoding UTF-8. So question mark, auto reconnect true, character encoding sets to UTF-8. Next, the user for accessing the database with the password. Validation query will be the select one. And one additional property is the Spring data source driver class name. And this would be the MariaDB JDBC driver. Also, quick mention, all of these properties are covered in the documentation, and they are provided for all of the supported databases. Next, what we have is the configuration of the internal broker. In the previous versions, that is the 4.12 and lower, the internal broker was embedded, and the configuration differed a little bit. Now in the internal broker URLs, we are basically putting the IP addresses where the internal broker is running. Also, we can see that we are using the failover string, which tells us in case the first IP address is not accessible, the second one will be used instead. So for the ECP, it is just the internal broker URLs. Going into the internal broker section, I can edit here. So failover string protocol will be the IMQPS. Next will be the IP address of the server. So to copy that, went to the connections. Followed by the point where the IMQPS is listening on the internal broker, followed by the comma and the other address. Going back to these properties, we can see the configuration on how to connect to the server, to the internal brokers. We can see that we will be using authentication. That means the endpoint and password will be used. Next, we can see the SSL configuration properties. That would be the key store properties. We can see the location, and that by default, the out key store is used. With password and out alias will be the ECP module out. Quick note about this, the out key store from the version 4.14 contains additional certificate authority, and that is the ECCo Artemis internal broker authority, so the endpoint can connect to the internal broker by default. Internal broker, we will see that in a moment, contains key store JKS, which also contains the certificate authority. This was covered in a little more detail in the previous webinars. Going back to the presentation, we can also see the information about the IMQPS security. It is described in the documentations as seen here. For the authentication, as we are using the IMQPS, we will be using the JKS key store with the password and also the user credentials. Going back, I will proceed with the configuration of the EDX toolbox. The configuration files would be located in the EDC folder EDX toolbox. Once again, EDX properties. And I will start with the high availability properties. So once again, the property for identification of this toolbox in the cluster, by default EDX01. However, I will once again use the sidebar name. Next, scrolling down, you will be able to find the Spring profiles active. And once again, we will enable the EDX-HA located above the internal broker configuration and below the database configuration. As we can see here, once again, the properties with simple values. Next, we will configure the database source. We can see that on the toolbox, by default, we have these properties already default in with the default configuration for the Derby database. So I will just copy these and comment out the old ones. So the JDBC connector will be pretty much the same. So I will just copy it from the ECP configuration. Once again, the name of the JDBC adapter, IP address with the port number, the name of the database or the scheme, that would be the WebTB slot, followed by the auto reconnect true and character encoding set to UTF-8. Next, the username the user will be using is the WebTB slot with the EDX password. Validation value and test number set to true. What we are missing now is the driver.
Yeah, actually, you've accidentally commented the EDX toolbox data directory property. That will be also used in some other properties.
If we will search for it, we can see it.
Yeah.
It is used, for example, for the location of the key stores.
Yeah, and also the validation query will be select one, and the values one is only for the Derby database. Most of the external database is using the select one, except the Oracle database, which is using select one from Dual. However, as Michael already mentioned, all these information, all these informations are mentioned within the documentation, and it's documented for like each database. So as well as the database driver, it will be described there.
Yeah. And once again, the configuration for the internal broker. However, on the EDX, we can see two properties instead of just one. And that would be the first one, the EDX broker URL. That's the property used for the internal broker of the EDX toolbox. And the ECP broker URL is the property used for the internal broker of the ECP endpoint that we are connecting. In most of the setups, also in the one we will be using here, the properties will have the same value, as we will be using shared internal broker for both EDX toolbox and ECP endpoint. So here we can see preferred EDX broker URL. Second, comment it out and replace it with the failover string. That would be the IMQPS. Here we can see that we are reusing the internal broker IMQP host defined on this line with the default value 127, basically the localhost IP address. However, I will be using the IP addresses, same as on the ECP endpoint, followed by a comma, and the connection string to the other internal broker that we will install in the second part. I can copy this now and put it into the ECP broker URL. Once again, to cover the internal broker and TCP broker configurations in general, we can see that for the authentication, we will be using user toolbox password for both internal and ECP brokers. Quick note, the toolbox user is not created on the internal broker by default. We will have to create it, but we will get back to this during the installation of the internal broker. Same as on the endpoint, we can see the internal broker key store properties, which is pointing to the key store JKS, the default key store of the EDX toolbox, where the out alias EDX module out can be found. Once again, the key store is already containing the ECCo Artemis certificate authority, so the toolbox can connect to the internal broker by default. And just to maybe avoid little confusion here, we can see these two properties. Also, although they are filled in, they will be ignored. The EDX broker URL and ECP broker URL have higher priority than these two properties, so this will be ignored. So you can either comment them out, delete them, or just leave them here. So this would be for the internal broker configuration. And for the EDX toolbox, one additional property that we have to pay attention to during the high availability setup is the EDX toolbox data directory. And we will have to set this directory to point to some shared storage that will be shared between all of the nodes in the EDX toolbox cluster. And it is actually the property that I have commented out by default, pointing to the varlib EDX toolbox. On the server, I have already prepared the shared storage. For me, it will be the opt/ha followed for the EDX toolbox. I will just copy that. And I can put it here. This means the folder will be shared for the toolboxes. Moving up, I will have to get back to the single deployment properties. That would be the toolbox code and service catalog code. So the toolbox code for us will be the slot VP. And for the service catalog, it will be the elephant. Actually, sorry, it is just slot. And as a service catalog, we are using just elephant. And one more property that we will have to configure is the DMS folders, which are by default commented here. We can see the little information that by default, if the property is commented out, the system get property Java temp directory will be used, but we will have to set this to the shared folder also. And as visible on the server, I have prepared the DMS folder for the DMS content. So that will be everything.
Yeah, maybe just mention a second DMS that is there, because this is like the general one. And yeah.
So what we have done here is we have configured the DMS folder. That is the regular push messaging that will be most likely used. But then we have to configure also the pull DMS folder, or we will have to configure it if we will be using the pull messaging. This has to be also pointing to some shared folder on the file system, so the toolboxes in the cluster can share it. However, as we will be using just the push messaging, I will leave it commented out. But once again, you would put something like this here. It will be the root directory in which the inbox and outbox folders will be created. Or in the toolbox terminology, it will be the input and output folders. Back to the presentation. We can see that we have covered all of the configuration for the endpoint and toolbox. Next, we will proceed with the configuration of the ECCo internal broker, the Artemis. The configuration is located going from the root, will be in the OPP, ECCo Artemis, etc, and the file broker XML. Just a quick note, all of the configuration or the most important configuration properties located in this file were already mentioned in the new features webinar, so I will just go over them briefly. So starting with the first part, that would be the shared storage. As already mentioned, the ECCo internal broker, or let's say the ActiveMQ Artemis, is not using external database, but rather it is using file journal, which will have to be located in a place on the file system which is shared between all of the nodes of the Artemis broker. This will be configured in these 4 properties. Back to the configuration, it is located on the top of the configuration. And once again, I have already prepared the folder that we will be using, and it will be the OPTHA ECCo Artemis, or Artemis. So I will put just this path to the properties here. By default, we could see that just the data folder was mentioned. That would be the relative path to these folders from the current folder. We are using absolute path, as we can see here. Next, we have the cluster connectors. The connectors, as we can see here, we can also what I have forgot to mention, that all of the properties that have to be configured for the high availability setup needs to be are marked with the command starting with HA. So scrolling down, we can just look for the HA command. We can see it here. And next, what we have is the connectors configuration. In this part, we are configuring connectors for the Artemis, where we will have one master connector. This master connector will be pointing to the Artemis instance that will be used as a master instance. So once again, I will just copy the IP address. with the port 61616 and say a slave connector, which will be used for connecting to the slave node into cluster. We will better understand for this further down in the configuration. So for now, let's just define this. Next, we will have the cluster acceptor that is by default commented out. So once again, the HA mark. And a little more, let's expand a little more on this. By default, we can see just the acceptor for the IMQPS communication, indicated by the protocol's IMQB in the properties for this acceptor, and the port 5672. This is the port where the internal broker is listening for the IMQPS connections. So it is used by the endpoint for connection or the business application. And next we have the acceptor, by default named just Artemis. We can see the port 61616. And then the protocols enabled on this acceptor is the core protocol. We will have to enable this acceptor, so the Artemis will listen for new connections. As we can notice, the connector created here is referring to this acceptor. So here we are saying that this internal broker will be listening on all of the network interfaces for this server and port 616. In this section, we are saying that when we will have to connect to the slave, we will connect to the server, to this server with this port. And next we will start a little larger chapter in the configuration for the cluster. We will start with the cluster configuration or authentication. Once again, let's see the mark for the high availability setup. And by default, we can see the HA defined with this default password. Also, of course, this is recommended to be modified in your installations. Next, we will continue with the cluster connections. We will define a cluster connection with the name of HA cluster. You can set this value to anything, but we will using the HA cluster, the default one. And next, we can see node that we will comment this section only on the master node. As this will be our master node, I will comment this out. Here we are saying that we are referring to the master connector that we have defined in this section, also with the slave connector. And basically we are saying that this is the master connector, and when connecting to other nodes in the cluster, we will find the slave node on this connector. And of course, to close this section, we can skip this section as this will be uncommented on the slave node. Next, we have the HA policy. So to get more information on this, in this part, we have created Artemis cluster, which is used by the Artemis to for all of the nodes to communicate between each other, to announce that they are live, that they can connect to each other, that they can be used. In the next, the HA policy, we will be choosing whether we want the shared storage, which we will do, or we can set the configuration for the network synchronization of the journal, but this will be not covered, and as well as this was already mentioned as not supported one, but possible. So once again, I will uncomment the master section, and here we can see that we will be the master node, and configuration for us will be that when we will be shutting down the server, it will announce that it is being shut down to the rest of the nodes in the cluster. Next, we have the slave node section that we will get back to on the slave node. Once again, I will close the XML tags. Scrolling down, we can see that this will be everything for the HA configuration. So to briefly just go over the configurations, we set the shared storage. Then we have set up the cluster connectors that will be used to connect to other nodes in the cluster. Then we have defined the cluster acceptor that will accept the connections from the rest of the nodes in the cluster. Next, we have defined cluster authentication. This has to be defined the same on all of the clusters. And next, we have closed with the cluster connections configuration, where we have defined the high availability cluster. The cluster will be used for the communication of the nodes between each other. And next, we have set up the HA policy where we have defined that we will be using the shared storage as to share the messages between the nodes. That is because, as already mentioned, the Artemis HA is running into active and in the master slave setup, where only one of the nodes is active and only one node will actually expose the IMQPS port. This is the same behavior as on the ActiveMQ Classic. So yeah, but first let's get back to the internal broker configuration, because I have just done the HA configuration properties. As promised, just to mention the acceptor, here we can see that the acceptor is using this key store. The key store is provided with the installation by default. It contains the certificate authority that is valid for 10 years. And actually it is also contains the certificate key pair on the internal broker. We can see that SSL is enabled and that we are listening on the port 5672 on all of the interfaces of this server. Protocol is the IMQPS and the protocol is IMQP, and enabled protocols, that is the TLS, is the 1.3 by default. However, in the documentation we can find that we can enable the TLS 1.2 if desirable. However, of course, not recommended. I will save the file. Going back to the configuration folders, we will have to configure the toolbox user. As mentioned, the Artemis comes only with the endpoint user, with default password being password, which we can see is by default hashed, meaning it is not in the plain text. However, I will have to define the toolbox user. The syntax is the username followed by equal sign and the actual password. On the new line, going back to the Artemis roles, that is the second file we will have to modify. In this file, we can see that there is IMQ role defined, followed with equals mark, and that the user endpoint, this one, is assigned to this group. I will have to assign the toolbox here as well. That would be done with the comma followed by the username. Make sure that you are not using spaces here. So that would be for the configuration of the Artemis for both endpoint and toolbox. And close these. Next, we will configure the Artemis internal broker to be accessible from the internet, or let's rather say other servers. This will be done in the Bootstrap XML and Yolokia Access XML. First, I will start with the Bootstrap XML. In this configuration file, we can see the web console definition that by default it is listening just on the local host. I will change this to be the 4 zeros, which basically tells us that the console will be accessible from anywhere, not just this server. And of course the port 8161 for the GUI. What we can put here is the IP address of the server, but basically it has to be something accessible from other servers. So the local host is accessible just from the server. The IP address and the 4 zeros are accessible from remote destinations as well. Going to the Yolokia Access XML, this file basically secures the cross-origin requests, and by default, once again, just the local host is here. What we can do here is that the origin will be pretty much anything. The asterisk is used to match any string. Alternatively, what we would put here is the IP address of this server followed by port. However, this was covered in more detail in the features webinar, so I will just leave it in the simple configuration, matching any source. Close these files. And this should be everything for the configuration of the first node of the cluster. In this part, we will proceed with the configuration of the secondary nodes of this cluster. We can see that on the endpoint and toolbox, only properties that we will have to modify are the local instance ID and the node ID, and the rest of the configuration will be the same as on the master node, or rather the first node. On the internal broker, we will have to pay more attention to the configuration, as we will have to switch the configuration from the master to the slave. But we will show that in a moment. And after that, we will proceed with the registration. But first, let's configure the second node of the cluster. Connecting to the other server. Once again, I have prepared the installers. So let me quickly install the applications. So connect once again to the Inkscape and open the configuration in Visual Studio Code. So I will start with the endpoint. So once again, etc/ECP endpoint, the ECP properties. And now what I can do is go to the first node configuration, and I will just copy the whole configuration and just paste it here. But as mentioned, what I have to pay attention to is the local instance ID property. I will have to modify it to be unique in the cluster. So for me, I will put the name of the server that is done in 5. For the EDX toolbox, going to the EDX toolbox, EDX properties. Once again, I will go to the configuration that we have already done. I'll copy it and just paste it here. And what I will have to change is the EX2 node ID. And once again, I will put the lane 05 here. So that will be configuration of the second node of the cluster for the endpoint toolbox. And next, what I will go configure is the ECCo Artemis. Once again, OPT, ECCo Artemis ETC. And this time, I will start with the general configuration, just to swap the order. I will open all of the necessary files. With the Artemis roles, I have to assign the toolbox user to the IRQ role, define the user and the Artemis user's properties. In the Bootstrap, I will enable the console to run on all of the interfaces. In the Nokia access, I will enable the access here as well. The console will be later used for the verification of the ECCo cluster, Artemis cluster. Now I will just copy the configuration from the first node and paste it here in the second one. But going up, we can see the shared storage being configured. That is correct. Next, we have the master-slave nodes connectors. We don't have to change anything here. Just make sure that the master node, in this case, the slave node, the slave node is pointing to this server, and that in the configuration we'll have the slave configuration. The Artemis connect acceptor will be the same. Next, we have the cluster user and password. This must be same as on the first node. Next, we have the cluster connection, where I will comment out the master and uncomment the slave. So what we have switched is that this connector is now referring the slave, and the static connectors is referring the master. This is what I have mentioned to make sure that the slave alias for the connector is this server IP address. Going down, we can see the HA policy. I will comment out the master and uncomment slave. Once again, you can see that for the slave configuration, we have the failover on shutdown. In case this server will be shutting down gracefully, it will announce it to the cluster. But next, additional property is the allow failback. This property basically tells us that in case this slave becomes master, because the master went down, once the master comes back up, we will restart it or correct the issue with the master, and the master announces it's present in the cluster. The slave will give up the master status and give it back to the master node. And yeah, this should be everything configurable. So what we will now do is to proceed with the registration process and verification of the installations. For the HA mode, we will start just the first nodes, just the first node of the endpoint toolbox and Artemis broker. The second node or all of the rest of the nodes will be stopped. Then we will verify the installation that everything is up and running, We will register the endpoint to the component directory, check that the toolbox is well assigned in the service catalog. And after the registration process, we will start the second nodes, where we will have verified the high availability working as expected. So going to the first server, I will start all of the applications. I will of course start with the Artemis. With the Artemis instance, because the endpoint and toolbox will connect to it. I will go into its logs. Artemis log, just to verify everything is up and running. As you can see, the web console is started on all of the interfaces, the port 8161. And also that the acceptors for the core protocol and LMQP protocol are running as well. Next, I will start the ECP endpoint and EDX toolbox as well. As the toolbox is connecting to the internal broker that is shared, we don't have to wait for the endpoint to start. In the 4.12, the connection from the toolbox to endpoint was made directly. So in case the endpoint was not running, the toolbox would throw an exception at stop. So going into the logs of these, that would be in the bar log, ECP endpoint. Going to the Catalina, we can scroll down, we can see just info logs, so everything should be fine. And in a moment, we should see that the web GUI has also started. It would be the Catalina log. A little higher, we can see the liquid-based logs. This basically tells us that we have successfully connected to the database. But in case we would fill in, let's say, incorrect credentials, incorrect JDBC connection string, we would see an exception here, and the endpoint would not start. Going into the ECP log, scrolling down, we can see that we cannot see anything suspicious, and that it's already started. You can see the camera road being started, and that the application was started as well. Quickly, I will go to the EBX toolbox logs as well. Scrolling down, we can see that the web console actually did not start for the toolbox. That is because we are using a single server for both endpoint and toolbox. And what I have forgot to configure is that by default, toolbox is using the 8443 port as well as the endpoint does. So we will have to change that. This would be configured going on the master node in the etc systemd system and EDX toolbox. This is there is chapter in the installation guide that covers this in a little more detail, and we can see the 8,000 ports. What I will just do, I will select all of the 8s and replace them with the 9s. So we can see that the toolbox will be running on the port 9443. I can close this. Quickly, I will create a path and configure the same on the second node. Once again, I will replace the ports from 8 to 9. And going back to the server or servers, what we have to do is to issue the systemctl daemon reload on both of the servers. And now we can restart the EDX toolbox. Going into the Catalina log, I will scroll down to the end of the file so we can see the newest logs. We can see the Liquibase running. Without any issue. Here we have the summary of it, of all of the change logs. And we are now waiting for the Catalina to start the web server. In the meantime, I will open the web GUI for the endpoint. That will be the for report. I can log in and I will be greeted with the registration page. I will also open the component directory where I will download the registration install. I can just import it here, fill in the default password. Now I will get the component directory URL, the component code. For us, it will be the Zoom CD. Check the connectivity. That was successful. Fill in the component code. For us, it will be the slot in the project name. I will put the webinar and environment name. I will put the name of the server, the lin4. That is the same that I have used for the cluster ID, just so we can orient a little better. Fill in the company information. Accept the GDPR disclaimer. That has been accepted. And now we will be redirected to the dashboard of the endpoint after the configuration reload. On the dashboard, we can see that we are waiting for the approval on component directory and there are no message paths. Now going into the component tab, I can just approve the registration request. In the reference point, we can see just that the endpoint is not registered. In case it could not connect to the internal broker, we would also see message informing us that we cannot connect to the internal broker. Now going back to the logs. To the ECP log, actually, as we have not visited that one. In case it would not be possible to connect to the endpoint, we would see errors informing that the connection it is not possible to the broker URL followed by stack traces with a little more information. Going into the EDX log. We can see an exception that the keystore.js could not be found. So to address this, by default, maybe I will open the configuration to see this better. The EDX toolbox data directory by default points to the varlib folder, but we have set it to the optha. This property is then reused for the key store location for the internal broker and TCP broker, and we can see the key store JKS that is not possible to be found. So going to the varlib, to the EDX toolbox folder, we can see the key store defined here. So what I will do is to point, instead of to the data directory, I will just copy the path here. I have to make sure to is to also switching to the other nodes, configure it here. Back. I will quickly restart the EDX toolbox. This is, by the way, the reason why we could not find the application starting log in the Catalina log. Once again, going down into Catalina log, we can see the Cubase running well. And this time, the server has started up, and we will be able to access the GUI. Going to the EDX log to verify this, we can see that the roads have started and that we have obtained the master log. We have over, that is us, and also we can see that the network configuration request was already sent. But what we can't see is some error logs notifying about not being able to connect to the internal broker. Going back to the web console of the ECP endpoint, we can see that we have been registered successfully, and we have to define the message path. I will create a new message path that will be indirect through the Gorilla broker. I will save this. And on the dashboard, we can see that the endpoint is well registered. This dashboard panel, we can also see the messaging statistics for the Gorilla broker, and that we are already connected to the Gorilla broker successfully. We can also see that the message, some message out, that there was already one sent message. That will be the EDX internal configuration request from the EDX toolbox. So I will open the GUI for the EDX toolbox. I will log in. We can see the GUI is running, that is good. And in the settings page, we can see the network configuration with the service catalog that we have configured to be Elephant. Now I will open the service catalog. Going into the configuration tab, I will download the latest version just to verify that the slot endpoint or toolbox was well added to the configuration. We can see it was going, let's say, to the toolboxes tab, to the toolboxes. We can also see the toolbox defined here. However, as we can see, we have not yet received any network configuration. Going back to the endpoint, refreshing the outbox, we can see that there were two network configuration requests. However, we have not yet received any. This is most likely caused by the TCP network synchronization, and that is the endpoint of the EDX service catalog. It's not yet synchronized with the component directory, so it does not know about the endpoint yet. In the inbox, we can see the messages being received. This indicates that the elephant endpoint is already synchronized, and in the outbox, we cannot see the service catalog replying. This is from older installations, older webinars. This can be indicated by the sending time. So to further investigate this, I will go to the service catalog log and see what is causing an issue here. Going into the EDX log, scrolling down. Yeah, in this log message, here we can see an error that is informing us that the slot toolbox is not reachable on the network Zoom or the ECP broker. So what's too complicated? I will start on the endpoint and just try to send a connectivity check message to itself. That would be in the settings page, and I will select the slot endpoint. This is us. Try to send this message, and we can see the connected message. Going to the elephant endpoint, to the settings tab, I will also try the connectivity check to the slot using some testing message type. And we can see we are connected as well.
Yeah, so probably caused by synchronization. Maybe very quick.
Maybe it was. I will request it once more just to see if the network was synchronized. Looking at the time, it is 11:40. That will be the synchronization time. However, we have still not received the configuration. But I suspect that going into the network configuration, we can see the Zoom physical network code find here. We find.
Yeah, actually on the slot endpoint, the MQP API is not enabled. Yeah, one of the common things that can happen. It's easy to forget from time to time. So yeah, it is necessary to configure the MQP API to configure it to send it to the EDX. What basically happening now is that the EDX network is basically correctly configured. Just the endpoint is not pushing the messages to the EDX. So
yeah, so to just summarize what just happened, the first issue that we had is that the elephant endpoint was not yet synchronized with the network, so it did not know about the slot endpoint, so it didn't want to send a message to it. That is logical, but after the synchronization, we can see that the slot has sent the elephant, has sent us the network configuration. However, we can see it being in the deliver state, and that it is not downloaded by the EDX toolbox. To enable the MQP API to send the message to the toolbox, we will just quickly go to the runtime configuration, and we will enable the endpoint MQP. We will set this property to true. Next, scrolling down, we will find the receive handler bean name and the class name. the receive handler configuration. But, yeah, just handler, that is what I'm looking for. And here we will enable the IMQP send handler. This is the default implementation, and enable it for all of the message types. I will save the configuration. And now I will go back to the slots toolbox, request the configuration once more. And after refreshing the page, we can see the service catalog network configuration being well received. What we can also do is a quick connectivity check to the elephant endpoint. I will just use some test message type and send message from the EDX toolbox. I will send, let's say, the registration keystone. And here we can see the message was successfully sent. Going to the elephant endpoint. Here we can see the message was just delivered because the IMQP API handler is enabled just for the EDX internal configurations, messages, and the service catalog. So I can now download it and go back to the toolbox. The message was not yet received.
Yeah, if you go back to the runtime configuration of the slot, I think you filled in the class name and not the bean name.
Yeah. Basically, what this send handler is doing is it is resending the acknowledgements, and I have filled the class name instead of the bean name. So one more attempt. I will send a new message to the elephant. Test the valid state quickly. The registration is done. Now we will be able to see that the message was delivered, hopefully. Should be. Yes. Just to verify the configuration once more. Sorry for that. There should not be any typo. But if you see the message being received, we will not bother with this now, as we are running a little bit low on time at this just a little inconvenient in our messaging, but we can see the message being well received on the elephant endpoint. So yeah, I will now proceed with the starting of the slave nodes. I have started just the master nodes. I will start the ECCo Artemis first, and let's open the web consoles for it. So first, I will open the master. What we can see now here that we have logged in successfully. We don't have any error message. However, this is a limitation of the Artemis console, and that is the some incorrect using working with the cache probably. So I will have to remove all of the cache data. And now I should be able to log in. This was also mentioned on the previous webinar. So, but once this happens, you need to clear the cache for this URL or the whole browser. But yeah, this is the master node, and we can see on the dashboard, you can see cluster info. that there is one lives, one backups, and that the HA policy is the shared store primary. The lives, that would be us, and the backups would be the backup server. So what we can do is go to the broker diagram here, and we can see diagram of all of the queues and addresses. This is our server, and here we can see the backup server being well connected. Going to the other node, and refresh the page quickly. I will log in. And we can see here, once again, that there is one backup on live, and that there is a shared storage backup policy. Going back to the broker diagram, this time, this is us, and this is the master node. We cannot see the queues here. Going to the queues tab, we can see that there are no queues. Going to the in this bar, we can see just the cluster connections running and no other cluster, no other connectors. Going back to the master, we can see acceptors. That is the AMQPS internal acceptor, the Artemis acceptor, and that we can see also all the queues. That is because only one of the nodes is a master, so that is correct. I will now proceed and start the rest of the nodes. I will start with going to the log file of the Artemis broker. And what we can see here, that although the web console has started, we cannot see any log that would inform us that the acceptor for the IMQBS would start. So that is correct as well. I will now open the logs for the ECB endpoint and see whether the other node has connected to the database. We can see the liquid base here, and we can see that that was just six of the changes that ran and previously ran, that would be by the master node, was only around. So this would indicate that we are connected to the same database and the GUI has started. So I will open the tabs for the endpoint that works. Going to the endpoint. I'm logged in. Although we can see the lane 04, that is because the environment name is shared between both of the nodes. So although I wanted to make it a little clearer, we will be a little more confused rather. But what we can do now is to send a test message to the elephant from the endpoint. Just from Edva, or let's say rather the link 05. I will send a message going back to the elephant endpoint. I will have to refresh the page as we have cleared the cache. You can see the message being received. You can download it, and on the outbox of the node, we can see the message being received. Now going to the toolbox, I will open its logs, the Catalina log. Just once again, you can see the liquid base already run. So we can notice that precondition for this change set failed because it is just for the Oracle, but we are using MySQL. Just a quick little detail that we are in fact using MySQL. We can see that the server has started. Going into the EDX log, we can see that the toolboxes started as well. Going to the GUI. Going back to the GUI, we can try to set a test message to the toolbox Arduino 5. And we will send it to the elephant. Try to send the registration key once again. You can see the message was delivered. That is the, you can see that it is not just successfully sent, it is also delivered, meaning the acknowledgements were well received from the endpoint to toolbox. And going back to the elephant, we can download the message. Refreshing this page, we can see the message was received. To address the previous question, in the dashboard, we cannot see that we are running the HA setup, unfortunately. However, for the Artemis in the status dashboard, we can. So yeah, this would be for the installation and for configuration of HA cluster. So maybe if there are any questions?
Yeah, doesn't seem to.
So yeah, regarding the integration of your business applications to the ECCo clusters, we will start with the IMQP protocol. We can see on the diagram that we would be running the internal broker in HA. Then the business application would connect to both of the nodes using the failover string. This is pretty much similar to what we have done in the endpoint and toolbox configuration. And then by default, we will be fine-tuning the queues on the active node. And in case the active node goes down, the failover connection string would switch to the passive internal broker that would start and enable the queues there. The failover connection string is a feature of the IMQP client, so this might differ for your language, programming language, or for your environment. Next, we would have the FSSF. In this case, the endpoint would have a configuration for the file system shared folder. The folder would be shared between both of the endpoints, and the business application would be accessing the file system to send the messages. In the FSSF, we would find the inbox and outbox folder. Yeah. And last covered here is the GUI, or rather the web service. To integrate to it, the business application would either have to implement its own process that would either try the first node and then the second node. What is good to mention is that both of the endpoints are pretty much active, and we can send requests to both of them, no matter if the node is master or slave. Optionally, we can use some load balancer, so the business application can connect just to the load balancer, and the load balancer will split the traffic between both of the endpoints. And that would be for the integration channels, how to configure them and how to connect to them in a little more detail. That is covered in the documentations. So, for example, the FSSF, you would have to use specific format for the file name. For the IMQPS, you would have to specify specific headers for the message. So once again, there is space for questions, and after that, that would be everything for us from us.
Yeah, probably no question. So in that case, I would like to thank you for participating and for paying attention to this webinar. And yeah, see you on the next one. Yeah, yours.
Sorry, I think I was not audible. Okay, so thank you for joining. And if there are no questions, we can close the today's session. And as I mentioned, it was the last session for this year on ECCo. But if you have any queries or questions, you can always reach us by our email ID at ecp@entso.eu. And or if you have a Jira access, you can raise a ticket there. The recording from this one will be uploaded on the YouTube channel by next week. Meanwhile, is there any comment on the chat? Sorry.
That is pretty extensive question.
So I think the performance test, this is the first question. The performance tests are being currently done, I think.
Yeah, for the OPD project, the one specific for the ECCo only will come a bit later.
Yeah, so for performance point of view, because it is used by several projects. So currently OPDE project is running the performance testing using the ECCo version, Artemis version 4.15, the current one, which we are going to release, as I mentioned. Also, we have our own plan for ECCo to do the performance testing. So for that, the environment preparation is still in progress. So hopefully by November, we will have an environment up and running, and then a performance testing will be conducted by the team, and the results will be available. So most probably we are looking like, and we will use release 4.15, which is the current release or the fall release, which we will release. And the results most probably will be available if everything goes by as per plan in January next year. I'm not sure about this question. If you, second part of the question raised by Marcel. Marcel, if you can specify specifically or you can detail your question, please, related to the protocol, zero redundancies. Can you hear, Marcel?
Yes, thank you. This
Yeah.
is a question from my colleague, which is not in the call anymore, so I can't
Okay.
specify this. Sorry.
Yeah, if you can, I'm not sure I'm able to understand it. If I just request if Unicorn team can understand that part. Means at least not clear to me, but Daniel, or do we need? No. So yeah, okay. So if we are happy to look into it and answer it, if your colleague can provide more detail and just over the email or so, we can help with this. So currently, when we test, we do FAT testing, and then the application is available for SAT, where we request the community to do the testing on their own test environment, and then the release is done. Performance testing, as explained, it's done once in a year, but this time for this year, we had an issue with the environment availability, and that's why the procurement process is currently in progress, and we are in process of acquiring it. So yeah, we can answer it if you can send us an email separately with a little bit more detail, please, and then we can answer to you. If there are no further questions, and so I wish you a happy and a good day, rest of the day, and we'll meet again next year, hopefully. And as mentioned, if you have any questions, don't hesitate to send us an email. We will help. We'll try to reply you as early as possible on those matters. Thank you very much. Have a nice day, everyone. Bye-bye.
Yeah.
Thank you. Bye.
Bye.
Thank you. Bye.
Thank you. Bye.